In this video, we're going to look at two free response questions that deal with parametrics, vector type situations that have been on the AP exam. First of all, an object moving along a curve in the xy plane has position x of t, y of t at time t, with the derivatives you can see there for time 0 to 2. Now again, when we've been given the derivative here, this means we've been given velocity. Time 1, the object is at the point 3, 2. Find the equation of the tangent line. Now, this was a calculator question, so I'm just going to kind of set this up, but of course we're not, I may not get all the answers, but let's just talk about it. Like part A, remember for a tangent line we need a point, we have it. Okay, at time 1 it was at the point 3, 2. We need a slope, we need the derivative. Well, we always do dy dt over dx dt to get dy dx. So at time 1, it's going to be the sine of e to the first, so just e, over the cosine of e. So there's our slope, and then we can type that in our calculator and write our tangent line. Okay. The speed of the object. Well, remember, speed is the magnitude of velocity. So we take our velocity squared and each part of the velocity vector, I should say, squared. So at time 1, we already have velocity. So we have dx dt squared, so we'd have the cosine of e squared and the sine of e squared. Okay? And that would be our speed. Okay? So if we type that in. Now total distance traveled, well, this is the arc length. So from 0 to 2, we set this up, that, and remember arc length is, it looks a lot like speed. We aren't evaluating at a point, though. We actually are putting the derivatives in. We already have the derivatives. So it's just going to be the cosine of e to the t squared plus the sine of e to the t squared dt. We'll type that in our calculator, and that'll tell us the total distance. It's the arc length. Finally, finding the position at time 2. Well, at time 1, we know the initial position, I guess, at time 1. So I would say, all right, the x-coordinate. I know that it started at 3, and the integral from 1 to 2 will tell me how much it changed from 1 to 2. That's the x-coordinate. The y-coordinate, well, it started at 2, and again the integral will tell me how much it changed, and then I'll be able to get the position, the x and y coordinate. So you just got to be careful with what you've been given, but certainly the question is not that hard. Let's look at one more. All right, here we have an object moving along a curve in the xy plane with that position. It gives us the part of velocity, dy dt, but then it says the derivative dx dt is not explicitly given. This has been really common on the AP exam in the past few years, to tell me that one of the pieces I don't know. At time 3, the object is at the point 4, 5. Okay, so then it says find the y coordinate at time 1. Well, I know its position at 3. Okay, and I'm doing the y coordinates. So I'm going to do 5 plus, and then I'm going to go from 3 to 1. And then we're going to have 2 plus sine of e to the t dt. That will tell me the y part. Now, you certainly could have done this. You could have changed the bounds to be the way you normally see them, and then just make this minus. But either way, what you're doing is you're saying, okay, how much did it change from 3 to 1? And then, finding how that relates to the initial position. Okay. B, it says at time 3, the value of dy dx is negative 1.8. Find the value of dx dt. Well, remember, the derivative is dy dt divided by dx dt. Well, I don't know what dx dt is, but at time 3, I'm going to have, dy dt is 2 plus the sine of e cubed, right? Just plugging 3 in. And I don't know what dx dt is, but I know this whole thing is negative 1.8. Well, I could do a little cross multiply or swap these two out, and then I would solve for dx dt, right? Dx dt would be equal to 2 plus sine of e cubed over negative 1.8. And you type that in and figure out what dx dt is. Well, then it says find the speed at time 3. Well, that's easy enough. Remember, speed is magnitude of velocity. So at time 3, we have, 2 plus sine of e cubed squared plus, now we need the dx dt part. I'm just going to write this. I'm going to write part B, because it'd be whatever answer we got in part B is what we'd plug in there. So we'd have the number for dy dt squared plus the number for dx dt squared, add them up, and square root. Okay, so again, these are two really common free response type of questions. One where we're given both parts and we have to use those things to answer a bunch of questions. Another where we're only given one of the parts and we have to solve back for the missing part.